Hello everyone and welcome to StaadPro online training program at SaiCad Center. And I'm your instructor. My name is Setu Nandania. And let me continue our today's session with the StaadPro software directly. So here I am sharing you my screen of the StaadPro. I hope this screen is visible now. Please confirm it once. Okay. I will answer your all questions step by step. We have one question from Tokir. So he is asking that why do we get 566 warning when we design concrete and zero error and warning when don't in second one. Okay, I will show you what are that warnings and everything. First of all, let me discuss our problem number 4. So you will get that answer over there, that what exactly that warnings are, right? And also the other answers from the other students. So just a minute, I am just going to open that assignment 4. Is this assignment is visible to you all? Okay, good. So in this problem we actually have to calculate with dead load, live load, wind load and seismic load, right? But the loading condition is not given over here, so we need to assume all the loading conditions, right? And one more dimension is missing, that it is this one. So that I told you that take it 2.35 meter. So let we create this model. So there are many ways to create this thing, right? You can create it with the any options. Let me create this with the structure wizard. So first of all, I will create a very basic frame model with the help of structure wizard, and we will focus only on this bungalow, right? Then we will mirror it to create the other one. This dimension is 2.35 meter. So first give me the sum of this all dimension: 2.35, 1.25, 1.15 and 3.35. So the total of that, and horizontal we have 3.4 meter. Just focus only on this area. So give me the sum of this line, this z line, z direction. So it's 6.85. Okay, so I am believing you, right? Actually I don't know the total. So new project, space, okay, yes, and finish. Turn off this thing, go to the structure wizard, and horizontal I want only one division, that 3.4 meter. We don't need entire, we are not going to create entire model. Just vertical division I want. So vertical division we have 6 point, what he says, 6.85. Okay, so 3.4 in horizontal, 3 meter in vertical, and 6.84, no, 85. Okay, we have one division in X, one division and three division over here. First one is 2.35. Second one is 1.25 and 1.15. So 2.4. And third one is, what is the third dimension? 3.35. Okay. So 2.35, 2.4 and 3.35. Okay. And we are having a issue. 6.95 confirm. 2.35, 2.4 and 3.35. Still we have problem. Why are you all giving me this type of answers? Just a minute, let me calculate. 2.35 plus 2.4 plus 3.35, 8.1. So we have 8.1. Okay. So again, geometry, run structure wizard, frame model, 3.4, 3 meter, 8.1 meter, 1 division, 1 division, 3 division, then 2.35, 2.4 and 3.35. Apply. So this is transfer it. Okay. Now we want one copy over here. So select this, right click, click on copy, right click and click on paste. In negative z direction minus 1.15 meter. So this beam is over here now. Sorry. Then next, now you need to focus in this area, right? So here first we have a horizontal distance 3.2 meter. So we will create that. So select this node, and you can copy paste also, or you can use this translation repeat in X direction, 3.2 meter. One copy, click on link step and OK, and select this again, translation repeat in Y direction minus 3 meter and link step and OK. So we have column also. Now 4.2 meter. Okay. So select this both, because we have a copy of this both. Right click and copy and right click and paste. In the Z direction 4.2 meter, right? Okay, so we have over here, it is correct? Yes, it is correct. Now a copy of that beam at 1.5 meter. So select this one, copy, paste, 1.5 in Z direction. Okay, and use this add beam tool and add one beam over here and here. Okay, now focus on your columns. So we have 3 columns over here and 4 columns over here, one here, here and here. Okay, so this is not necessary. This one is also not useful, and we want one column right here. So you can copy paste also, or just translation repeat, Y direction minus 3 meter, link step and OK. So that is it. Okay, one more thing, this is not actually a full division. See, we have some kind of gap over here, so we need to assume that thing also. So we are assuming this horizontal dimension as a 1.4 meter, right? So first we have to delete this thing, so delete it. Okay, and merge these cells. Okay, we will merge that later. Okay, merge it first. Select, go to the geometry, click on merge selected member, merge, and select this one also. Click on merge selected member. Okay, now again, so from here it's a 1.4, so from here it's a 2 meter. So select this, copy and paste in the x direction 2 meter. Okay, and then select this, copy and paste in the z direction minus 1.15 meter. Okay, so we have done our this um, first model. Now next we have staircase, and we also don't have a gap over here for the staircase, so we will take around 3 meter. Okay, so this gap is 3 meter for us, and here we have a mid span beam. So what we will do, we will do, okay, from here, so just copy this node and paste it at half distance, and then again select it, translation repeat in x direction 1.5 meter, half dimension, link step, and okay. So this is 1.5 meter, the total will be 3 meter gap. So now what I am doing over here, I am just selecting this entire model, not with this, with the beam cursor. Select it, click on the mirror, and we want to mirror about a vertical plane, so plane should be YZ. So click on YZ, and node, so node should be this one, around this point. Hit OK. So we have a mirrored copy. Okay, now merge these both beams because it's a single beam. Okay, done. So we have done up to this point. Now a mirror again on the other side. So select your entire model, go to the mirror. Now our mirror plane will be XY, right? This plane will be our mirror plane. So choose XY, and mirror point is this one. So here our mirror plane is there, so it will be mirrored. Okay, and on this side actually we have a lift, right? So this midspan beam is not necessary, so I am deleting it, and select these beams and merge it. Go to the merge, merge, close. Okay, now we have some beam arrangement for the lift over here. So first horizontal beam, then 1.5 meter, then 0.45 meter from both side. Okay, so add beam from here to here, select it, copy, paste in the z direction 1.5 meter, then select this, copy, paste in x direction 0.45 meter, then select this, copy and paste beam in x minus 0.45 meter. Okay, so that's it. This is for the our first floor, right? Now we want G plus 15. So before we continue, let we change the, can we import AutoCAD drawing? Yes, you can, but it will create some kind of problems because we have to insert a wireframe model. So yes, you can import, right? Just go to the import tool from the file and you can import your, not DWG file, you must have DXF file. Okay, so convert your AutoCAD file into DXF format and then you can import it. But that model must be in wireframe like this. Okay, don't create that entire thing in 3D. So select your node first and give a rename. So geometry, renumbering, node numbers, joints, accept, and again select with the beam cursor, geometry, renumber, members. Okay, member number, accept. Okay, sir. Yes, it is obviously better to use structure wizard. Whatever objects, see, structure wizard will not give you the exact structure that you want, but try to create something from that structure wizard, whatever you need. Then the rest of the thing you can model it yourself, right? But initial task, for the initial things, you can use that structure wizard, and then rest of the things you can create with the yourself. Now we want one more beam actually over here, this one, because at the beginning of the stair there must be a beam. So at 1.5 meter from this point. So I am actually we want to create that beam. So we are going to select this node, copy and paste in the Z direction 1.5 meter. What is this? Copy, paste. Okay. And now from here also copy, paste 1.5 and add one beam. Okay, done. Now select your entire model, go with the translation, repeat the Y direction, 15 copies we want at 3 meter spacing, hit OK. So this is our model, right? Then next we go to the general, assign a property. Let me define one. So I am just defining one property over here, whatever size you want, just give me any size. Let me take depth of 0.35 meter and width 0.3 meter. Okay, with concrete material, add, close, select it and assign to view. So I have assigned this entire property to the model. Then support, create fixed support, select it, take your front view, assign, and yes. Okay. And now for the loading. And as I told you, for the loading, first you have to work with your earthquake if you want to add the earthquake, right? So go to the definitions, create seismic definition with your code, whatever latest code you have. So I have 2005 revision, and share your information from the generate. If you want to provide some foundation depth, then turn on that, and my foundation depth is for example 10 meter, so you can fix it over here also. Then click OK and click on add. Now the loads, first self weight, then in the dead load we are considering 9-inch wall, or let we consider a partition wall, right? So 4.5-inch wall, we have 6.5 kilonewton per meter wall load, right? This is my wall load. Add, and floor load I am adding 6 kilonewton per meter square, and the range from 3 meter to 48. Add and close. Now this wall load will go to a select parallel to X and select parallel to Z. So on the entire model I am applying. If you want to skip this first floor, you can just deselect this first floor, top floor, sorry, because this top floor doesn't carry any wall, right? So if you want to remove it, you can, but right now I am assigning it. So assign yes and yes. So that's done for the I hope my screen is visible, right?
Yes. Yes, sir.
Niranjan? Okay. So we create this seismic definition. Now we have to add 4 load cases with seismic loading type. So earthquake X plus add earthquake X minus earthquake Z plus and earthquake Z minus. So after creating these 4 load cases, just assign a direction. So seismic X factor 1, then in the X minus, seismic X factor should be -1. In Z plus, seismic Z direction factor 1, and in -Z, seismic Z direction factor -1, right? Then create your dead load case and live load case. So one dead and one live. In the dead load case, we will add 2 loads self weight factor -1 and member load uniform force -6.5 that we have considered as a wall load, and both will assign first self weight assigned to view and wall load select parallel to X, select parallel to Z, assign yes. And in the live load we will add floor load. So click on floor load -6 and the range from 3 meter to 48 meter. Add and close and check it. Okay, done. Right. Then if you want to add wind loads, then create your wind definition. So again, wind definition, add wind 1, close, and add intensity over here. That 0.7 for first 5 meter, then 0.8 for next 5 meter, then 0.9 for next 10 meter, then 1 for next 10 meter. Let we take it this interval 5 meter, 15, 20, then 1.5, sorry, 1.1 for 25, then 1.2 for 30, 1.3 for 35, 1.4 for 40, 1.5 for 45, and 1.55 for 50 meter, right? So add your wind loading, wind intensity over here, then click on add. Factor should be 1, add and close, and don't forget to assign your exposure assign to view. Then and then your model will be detected, right? Then create 4 load cases for the wind load. WL X positive, category wind, add WL X negative, add wind load Z positive and wind load Z negative. Select it, add wind load X direction factor 1. I am just adding this windward force, okay? Leeward that we discussed in our last class, right? So you can enter like that. I am just adding windward with the factor 1. Add and close, then X negative. Go to the wind load X factor -1, then Z positive, wind load Z factor 1, and Z negative, add wind load. Where is wind load? Here, Z direction and factor -1. Add and close. So this is our wind load, right? Now to check that everything is correct or not, up after this point, just run your study once. So if there is any error, then we should stop our work over here and we can restart it again, right? Because we are going to design this thing and we are going to add combination loads. So before we do that thing, first just check it once. So command analyze perform and run your study. If you are getting no error over there, then it is fine. Now see, here we have one warning. So go to the StaadPro output, click on done, and check that warning. What we have? See warning. If this analysis has tension and compression or repeat load and reanalyze, so he actually getting confused that we have actually repeating load. See, repeating load we have, right? So actually we apply a same dead load to entire model, so that's a repeating load. That's why this warning is, right? So we don't need to worry about that warning. Now let we add the other things. and you will get so many warnings over there. So first of all, we will add a auto load combination and Indian code, new category, name it earthquake and wind. Okay, sorry, not new code, new category, earthquake and wind. In the Indian code, new category, earthquake and wind, and 7 rules we want. Okay, then 1.5, 1.5, 1.5, 1.5, 1.2, 1.2, 1.2, 0.9 and zero point 0.9, 1.5, 1.5, 1.2, 1.2, 1.2, zero point 0.9 and 0.9. Then click on update table. Your cells will be in white, right? Then click on close. Now go to the load case detail, click on add auto load combination, choose your category. We have Indian code and choose your table. Click on generate. So we have 55 solutions over here, 25. Add and close. Now again run it. So analyze and run. See, don't do this thing again. Command analyze, perform analysis. Okay, this thing you have to do only once in your problem. Once we have analyzed this thing, so now we just need to update our result. To update our result, you have to only run your analysis. Okay, so don't perform that again. Just run your study. So we have again only one warning over here. Now let we do our design module. Okay, so where is that question? Question is from, yes, Takhir. Takhir, now we are going to design this study, right? And you will get so many errors. Sorry, so many warnings, not errors. So click on design, concrete design, IS 456, parameter. Let we add concrete strength. This is for M25 maybe. Click on add and steel strength, add and track report if you want. Add and close. Right? Now see, always we have to analyze only for the ground floor. We have to check the reinforcement detail only for the ground floor. But actually we are doing this thing for the entire building. Okay. So we are going to assign this thing to entire model. But actually this study is only for the ground floor only. I will explain you why it is. Right? And design of beam, design of column and takeoff. Now the design of beams, that means our horizontal member. So select parallel to X and select parallel to Z. Assign, yes. And column means our vertical members. Y. Assign, yes. And again run your study. Now focus on the warnings. So Tokhir, are you there or not? Our warning list is rising. Hello. Tokhir, are you there or not? See, we reach at your question. Right now we have 336 warnings over here. Hello, am I audible? Okay, maybe he is not in front of his screen. No problem. So these are the warnings that due to this much members are there who is failed in reinforcement. That is why we have this warning. As I told you, when we done our design, you will get a concrete design, right? So just double click on your member and you will get a concrete design over here. But see, for this column we do not have that concrete design option over here. That means this member is going to fail. That's why we have one warning for this member. Similarly, there are 336 members currently are there in my model who is going to fail in the reinforcement detail. So if we check on the top, we have concrete design over here. That on the top we need to provide 16 member, bar size 16 mm, diameter and 8 number of members, right? For this top piece. Same for this one, we have reinforcement detail. For this one we have reinforcement detail. But as we go down, you will not get reinforcement detail for some members. We have for this one also, we have this one also, we have, yes, yes, concrete design is not available for only this model, this bottom piece, because this is a corner piece. Let we take um, some other beam. Let me focus on some other beam. For example, we are selecting this one, right? So select this beam, right click and click on new view. So here we have that column, and let me check a design result. For that we have concrete design. That means we have some kind of reinforcement for this member. For this also we have. From here, see, we do not have that reinforcement detail. Okay, so here we have 1 2 3 4 5 6 7 8. So top 8 floors are fine, but from the bottom we do not have that reinforcement detail. So that warning is due to this thing, because this column is going to fail in my reinforcement detail. So we need to increase the size of this column, right? That is our design and optimization problem. So here let me discuss our design and optimization problem, so you will get the exact idea. that how to optimize our model. Okay, so for that always you have to focus on your ground floor, because if your ground floor is going to save, if your ground floor is going to provide a complete reinforcement detail, then all your above four floors are safe, right? So let's have a new problem. So in our assignment 3, maybe, just a minute, I am going to open that. Yes, in our assignment 3 we have this problem that actually we get some error. Why, I don't know, but let we analyze this study again, right? And I will show you how to optimize this thing. So it is clear for problem number 4, sorry, assignment number 4, or you have any questions? Okay, now let we have a very small problem over here. So I'm going to close this study now. Okay, geometry, run structure wizard, frame model, length is 12.6, height is 12.8, and width is 0, 3 division, 4 division, 0. Okay, so this is our model, right? And now we will add first details, cross-sectional detail. So we are going to define a minimum cross-section size over here, that means 0.25 by 0.25, right? This is my minimum size. Add and close and assign it to the entire model. And now support, create fix support. This one should be over here, assign, yes, and load. So this is my load case, and this is my load, minus 50 kilonewton per meter. Add and close. This should be beams parallel to x, assign, yes. And let we analyze this thing first. So if we have any error, so we will get that comment. I'm not getting this thing. Why we have error in this model only? And this error is only for the support, error in support input. See, there is no support input, analysis will not done. Leave it. Let me take another model. Mm, length is 9 meter, height is 3 meter, width is 10 meter, 2 division, 1 division, 3 division. So 5 meter, 4 meter, and 3.5 meter, and 5 meter, and 1.5 meter. Geometry, select this geometry, renumber, members, member number, okay, and select it, translation, repeat, y direction, 3 copies, 3 meters, okay. Let me perform our analysis on this model. So again, general properties, define, use minimum size 0.25 by 0.25, add and close, assign to view, support, fix support here, and in the load, that we have one load case. This load case carries self weight, member load 12.5 kilonewton per meter, and also floor load -6 kilonewton per meter square from 3 meter to 12 meter, and this should be minus, click on edit, minus 12.5. Self weight assigned to view, this also going to assign parallel to X and select parallel to Z, assign yes, and command analyze, perform, and run the study, yes. Okay, so we have no error in this model, right? So we are going to design this problem. So now click on the design and go to the define parameters, not in define parameters, go to the concrete first and then define parameters, strength of concrete, strength of steel, and track of second level. Now you have to assign this parameter only for the ground floor, but for our reason I am assigning this thing to entire model, okay, but we have to always analyze only ground floor. If our ground floor is going to save, then entire model will carry that reinforcement detail. So design of beam, design of column, and takeoff, and here design of beam should be parallel to X and parallel to Z, assign yes, design of columns parallel to Y, assign and yes, okay. Now again run the study and see, our client requirement is that we must have a percentage of steel between 2 to 3% in ground floor, right? See, in our problem, our client requirement, this we can say our client requirement, this one, the percentage of steel in ground floor column should be 2% to 3%, right? So we have to maintain that much percentage of steel in ground floor. So let me check. So for this column we have percentage of steel 0.72%. See, that means this column is carrying a very less load. That is why StaadPro provides a very less reinforcement. right? Only 0.72% compared to your concrete. So area of your steel and area of your concrete, here is the percentage ratio we have. So that state suggests that we have to use 12 mm diameter 4 members, and this is the arrangement, right? But don't think that this is our 250 mm, this is just 12 mm. Okay, this is for your information only. So we are not able to go lower than this size, so we need to accept this thing, right? Let me see the other one. Here percentage of steel is again same, but on this column it's increased, see, 2.83%, and the suggestion is using 12 members 12 mm diameters, 16 members for this column. So for example, this column is not economical for me. For example, I have to maintain my percentage of steel from zero point 0.5 to 1.7%, right? Or 1.6%. So this is above my limit, right? So what we need to do, we need to increase the column size of this one. Similarly, you have to analyze or you have to check for all your ground floor. So we have 0.72% steel. Here we have 2% steel. See, 20 mm 4 member. And on this, again we have 2% steel. So these three columns carries much load, and the percentage of steel is higher compared to my requirement. My requirement is below 1.5% and above 0.5%, right? That is my requirement. So what we need to do, we need to increase the size of these three columns. So let me go to the general again and create one new size. This time we will use 0.3 by 0.25. We increase 0.5, 0.50, 0.05, sorry. So 50 mm size we have increased, right? Click on add and close. Now assign this from the top view on this column, this column, and this column. So for these three columns, we are going to change our size. Assign, yes, yes. And again run your study. So this process is known as optimization process. Okay. Now again check this one. It is fine, 0.72, which is economical. Now this one, it's also fine. See, now we need only 1.2% steel. So again, this is my economical column, right? Same for this one, 0.6%, which is fine. This one, 0.6%, which is also fine. So in this way, you have to optimize your study and you have to check each and every column for the ground floor. Now, whatever reinforcement you get for the ground floor, you have to copy paste that for your all the entire model. So if you check over here on the top, see that reinforcement detail will increase or decrease, right? That's due to miscalculation. But we have to focus only on ground floor columns and beams. Here, see 0.6%, and on the bottom we have 1.2% still, right? But still we have to provide a 1.2% steel in this entire column up to the top, right? So this is our design and optimization. So I hope you all clear up to this point. If you have any question up to this point, then you can ask me. Hello, are you all are there or not? How to transfer reinforcement detail to other floors? See, floor reinforcement detail is not available in our Indian code, right? But whatever information, see, go to the StaadPro output, click over here, and you will get a complete report for the stepwise. See, this is beam number 2. So the reinforcement detail for the top reinforcement of your beam, bottom reinforcement of your beam, and stirrups, that rings that we place, right? So at every 100 distance we have to place that rings. Similarly, you will get a result for the columns in the bottom, right? So these are steel beam we have. Now we have column designs. So here you will get everything. Column number 3, right? No, it will affect your report. See, in the report it is written over here that we are discussing about column number 3. So which one is my column number 3? So just turn on your numbers over here, shift B. So these are the our numbers, and this is our column number 3. See, and when you see your report, so this detail, this reinforcement detail is given over here is for this member only, right? So that's why we have to renumber, because there are many members which may create some confusion to you, not for the software, it may create confusions to you. So now here we have column number 8. So if you want to check the detail of that, then you have to find column number 8 in your report, and here that is, right? So in this column, actually see the steel requirement is 236 square mm, and the concrete requirement is this much. Main reinforcement provided 4 number of copies of 12 diameter, and percentage of steel is there is 0.72%, right? Tie reinforcement provided 8 diameter rectangular tie at every 190 center to center. So these are the information for column number 8. Same, let have a column number 9. So you will get the information of column number 9 over here. So see, the required concrete area is increased because we changed that column size, right? This column is 0.25 by 0.25, and this column is 0.25 by 0.3. That's why the concrete area is this much. Steel area needs this much steel area is required, but provided 8 number of copies of 12 diameter. So the provided steel area is 904. So uh, your provided reinforcement, provided steel area will always greater than your requirement, right? StaadPro will manage this thing automatically, and he will provide this is the required result, right, as per the analysis, and then this is the provided result. minimum we have to provide this much reinforcement, this much, right? So this is minimum requirement. You can use, if you are using 10 mm diameter reinforcement, right? So you have to increase number of members, but the percentage of steel must be this much, right? If you are providing 16 mm diameter members in the main reinforcement, then calculate yourself that how many members you need to get this much square area of your reinforcement. So that you have to calculate. And whatever reinforcement that we are getting for the ground floor will continue up to the top floor, right? So you don't have to decrease. See, on the column number 72, our reinforcement is actually going to decrease. Percentage of steel is 0.6% over here. And if you check on the first, then percentage of steel is 1.2%. So we are not actually doing this thing in real world. Whatever reinforcement that we are getting for the ground floor, we actually do the same reinforcement up to the top floor after 2001, because after the earthquake this is the new thing that people are following, right? But if you check that older structure before 2000, then a column size at the bottom is bigger one, and as you go on the top, that column size is going to decrease, right? But in the current situation, whatever column size you have on the bottom will go continue up to the top, right? And with the same reinforcement because of the earthquake. Yes, that we have to find out, Niranjan. The economical condition, economical position for the cost point of view, and that we have to find out, right? So which size you have to consider for your column, that you are getting a minimum or uh, around 1 to 1.2 or 1.3% of steel is there, that is your economical zone, right? So in this way we have to optimize our structure, and we have to decide the size of our columns as well as beams also. So now let's have a look on our next two problems, or our today's two problem. One is for the moving load. So how to apply moving load, right? So for that we are actually creating one bridge, steel bridge. So here I am creating that. See, we have a very few time left now. So just focus over here, and this is actually our last class, right? So this is our how bridge, and I am creating bridge for 50 mm length, 50 meter length, maybe 5 meter height and 5 meter width, and number of bays, let me take 8. Okay, so this is my bridge structure, right? I'm going to transfer it, okay, at origin, and this is my bridge. Now how to apply moving load? To apply moving load, I am creating first some beams over here on the center. So let we go to the front view, select this, right click and click on the new view. Okay, go to the top view, and here I want a 2-meter track, right? So I'm selecting this one, right click and copy and paste along the Z direction, 1.5. Okay, and copying this thing, paste minus 1.5. Okay, so we have 2-meter space over here, right? And this thing you have already watched in our video, so you might have no confusion up to this point. Now this is our steel structure, so I'm going to assign a steel property. So go to the property, go to the section database, and I'm assigning a I section of whatever size we have. So Indian code, I shape, and choose any one size. Click on add and close and assign this to our entire mode. If you want to view it in the rendered view, you can just turn on your rendered view and you will get this type of truss, right, with the I section. Let me add supports. So whenever you are creating a truss will always carry pin supports. So add pin support over here, and this support will be over here and here. And now we reach at our last position, that is moving load. So how to create vehicle load? So for that, first you have to create one definition for the moving load, right? So click on the definitions, vehicle definition, and here you have to create one vehicle definition. So your vehicle carry many wheels over there, right? Number of wheels, a pair of wheels are there, and the width of your vehicle you have to type here, that is 2 meter. And from the back side you have to provide a load. So for example, on my vehicle I have around let's say six, or not six, four pairs of tires, right? And the last tire carries 75 kilonewton load. Then second last tire also carries 75 kilonewton, and that is 1 meter away from my the gap between both the tires. Then press tab, you will get one more here, one more pair with 1 meter and carrying 75 kilonewton load, and my last pair is carrying 50 kilonewton, and it is 2.5 meter away from my this pair. Okay, so these are the four pairs of tires we have on my vehicle, and click on add and close. Now see, StaadPro actually gives us a static analysis result, right? And this moving vehicle is known as dynamic simulation, but StaadPro is only able to perform a static analysis. So what we can do, we can do one thing over here. Actually we can put our this vehicle at different position. First we will put at the beginning, then after 10 meter maybe, then we will put over here at the middle, then we will put over here, then at the end position, right? So in this way we will put our vehicle at the different position and we will analyze this thing. So as many time you will put your vehicle at different positions, you will get that much accurate result, right? So for example, I want to put my vehicle at every zero point 0.5 meter interval. So first I will place here, then analyze this thing. Then next I will place zero point 0.5 meter away and analyze this thing. Again 0.5 meter. So in this way it will take around 100 simulation to reach this point, because this is 50-meter length and I want to analyze it every 0.5 meter. So we need 100 vehicle analysis result, right? So go to the load case detail, click on add, and here you have to go to the load generation. This is for vehicle only, right? And provide how many load cases you want. So we want 100 load cases because we want to analyze 100 times. So type 100 load cases, click on add. If you want to analyze 50 times, then type 50 over here. If you want to analyze 25 times, then type 25 over there, right? Now select this and click on add and choose your vehicle type, which is type 1, and your initial position. Initial position should be our lower right corner, so this corner. But initially just leave it as it is and click add and close and click on this, so you will get your initial position over here. So now see, our vehicle is in backward condition, right, on the wrong side. So why it is? So just click on add, edit it, and width is 2 meter, and actually we need to reverse this thing. So this 50 kilonewton should be here, and 75 kilonewton should be here, and this should be 1 meter, and this should be 2.5 meter. Change it, close. Now see, okay, so this is 75, 75, 75 and 50, but this initial position, this should be here, right? So we have to find the coordinate of this point. So this is in z direction, and how much? 1.5 and 2, so 3.5 meter. So click on edit, and in the z 3.5 meter, change and close. So now it is at proper position. Now one more thing, we need to provide a increment value over here, that I want to go in the x direction, 0.5 meter, change and close, right? So this is the thing. Now go to the command analyze, perform, and run your study. So you will get 1500 different output. Go to the post process. So here we have separate 100 load cases. Okay, take a front view and just increase this displacement a bit so it is visible to you, and click on this loads button also, so this load is also visible. Now see, we are in load case 1, this load case 2 is 0.5 meter away, see. Then again load case 3, 0.5 meter away, load case 4, then use your arrow keys, 5, 6, 7, 8, 9, 10. So in this way we put our vehicle at this much different position, and we analyze our problem, right? And this, all the results will combine in envelope. So go to the beam result. These are the forces we have. Let me focus on the movement, right? So this is the bending moment in our model. But what we have to check, we have to check it for the maximum for all. So that you will get in the envelope. Go to the envelope and you will get the maximum of all condition. and we have to calculate, or we have to save our model for this condition, right? Same for the uh, shear force, and also stresses we have, right? So tension and compression zone. So that's it for the vehicle loading, right? Now let me discuss our water tank problem. So it is here, yes, in our assignment 5. First problem is create one steel bridge and provide any magnitude load and analyze that problem. Okay, so you have to do that. And now we have this water tank. So for the water tank, actually we need to create plates, right? So what we need to do, let we begin our model. This is actually a circular water tank. So we will create a circular water tank. So it is clear now for the vehicle loading. Do you have any questions regarding this? If you have any question up to this point, then you can ask me.
No question.
Just 2 minutes and I will be back. Meanwhile, if you have any question, then just type it in the chat box. Okay, so we have no questions. No problem. So let me finish our last problem, that is a water tank analysis, and the only critical task in that is that modeling. So how to model exactly that water tank? So let we discuss that. So new project and just focus on the modeling, right? So here I am creating, first of all we will take a 6 meter diameter. Let we check, we have diameter, no. So we will take 6 meter diameter and 6 meter height we have. So at every 2 meter I am creating 3 beams. So these are the 3 beams in the beginning, right? And we want a circular water tank, but we cannot create a circular water tank, right? It always become a polygonal water tank. So let we divide our water tank into 18 division. So every division will be at 20-degree angle, right? 360 by 18, so 20 degree. So I am choosing this nodal cursor, selecting these 3 nodes, circular repeat, y direction 0 0, 20 degree, 1 copy. Okay. So in this way I take a circular copy around y axis of these 3 nodes, and now we are going to add a plate over here, not just a beam, we are going to add plates. So go to the, over here we have also 4 node plates, right? So chord plate, and in the geometry add plate we have 2 types of plates, chord plate and triangular plate. So take this chord plate and creating this plate like this, and next again one plate like this, and now we need triangular plate. So geometry, plates, triangle, and here we have triangular plate, right? And then we will create a circular pattern for that. So take a plate cursor now, because these are the plates and you need a plate cursor to select that. Take circular pattern in 340 degree, because we have already 20 degree, and 17 copy. Click OK. So now we have a entire plate like this. Similarly we will create walls. So again select 2 nodes, translation repeat, the y direction at 1 meter, 1 copy, and create one chord plate over here, vertical one. So geometry, plates, okay. Now with the plate cursor select it and translate it in the y direction, 5 copies we want at every 1 meter. Okay, so this is our 6 meter height. Now select all these 6 plates and go with the circular pattern in 340 degree and 17 copies. Okay, so here we have a complete tank. It is clear for this tank. Now we need to create a support structure, right? So suppose for the support structure we will create first of all beams. So select your beam cursor and select it. So initially we have 3 beams over here. So actually I want to provide 6 beams for the support at the bottom, right? Here I need to provide 6 beams. So select these 3 beams, take a circular pattern around y-axis 360, 6 copies, and also link step. So this link step will create this thing. See, these all nodes are connected. So we have a web also of the beams. So just select your beam cursor and select everything. So you will get the exact idea that what we have created on the bottom for our support structure to support our water tank. Right. So these are the beams we have to support our water tank. Now we need to create a structure. So I am selecting these beams. Okay. And now we want a columns over here. So translation repeat in the y direction -5 meter, one copy, not one copy, two copies with link step. So when you do with the link step, your new nodes will created a beam, a member will be there, right? So this type of structure we have, see, this beam is due to link step, right? So make sure that you turn on your link step, and at last just select these nodes and translation repeat in y direction -4 meter and link step. So we have open end like this, so where we are going to provide our support. So this is our water tank that we modeled, right? So I hope this modeling task is clear to you all. So next we have almost same thing except these plates. So go to the general property and define one section for the beams and columns. So we'll use square cross section 0.3 meter by 0.3 meter, 1 feet by 1 feet. Jitendra, what you want to repeat? Entire model? Okay. So see, now focus over here, okay? So new space problem, okay, okay. And first of all, I have created three beams over here at 2 meter spacing. So these are the three beams. Then I want to create a water tank floor first. So we need 4 points to create plates. So I select these 3 points and go with the circular pattern. I just want one copy at 20 degree. So we are using 20 degree interval. Okay, so this is our circular pattern around this point, and then we create plates, chord plates, first, second, third, fourth. So this is one plate, then again second one. Then now we need a triangular plate, so that is also we have. So go to the add plates and here triangular. So these are the plates, and to select this plate we need a plate cursor, because with the beam cursor you are only able to select beams. This is beam, this is not beam, right? So click on the plate cursor and select your plates, and now we want a circular pattern. So click on the circular repeat y direction, one copy already we have. So we need a 340 degree and 17 copies. Click OK. So we have a complete plate over here. Now I want to create walls. So for that I do that same thing. Select these two node and translation repeat in y direction, 1 meter and one copy. Okay. So this is a translation repeat of node at 1 meter on the top side y direction, and plate cursor chord plate. So this is again my plate. Now select this plate and take more five more copies. So translation repeat y direction at 1 meter distance, 5 copies we want. Okay, so here we have total 6 plates. So this is my 6 meter height. Select this 6 plate and do circular pattern. So click on circular copy in 340 degree, 17 copies, and at the center click OK. So this is my tank, right? Now we are going to design our support structure. For that, initially we create 3 beams over here, right? You will get that thing with the beam cursor. Select beam cursor, select your model, all the beams will be selected. So we have, these are the beams. So what I am doing a circular pattern of these beams. I want 6 copies for the support. This is our beam. These are the plates, right? So select it, circular copy, y direction 360 degree and 6 copies. I want to add 6 copies. If you want to add 4 copies, then you can use 4. And also using this link step, so that hexagon will be created, right? Because that all nodes will be connected. So using this link step, okay. So this is our beam structure. See, from these 3 beam, we actually create this 6 beam, and due to link step, these all beams are connected from these nodes, right? Now from the I have selected this middle hexagon, and now we want to create columns. So I take this pattern in negative y direction, right? So again circular linear pattern, y direction, minus 5 meter and 2 copies. But I am also using link step over here. So this node is going to connect with the bottom one, right? Hit OK. So that is why we have these 2 members. Otherwise you will only get this hexagon. Similarly, I have selected these 6 nodes and repeat it, minus 4 meter, 1 copy, and also link step. Sorry, that's in X direction. Direction is Y, minus 4, 1 copy, link step. So now it is proper. So it is clear now how to model this water tank. Okay. So next we are going to assign properties. So go to the general property, define rectangular, and I am using square section, 0.3 meter by 0.3 meter, and select it. Select your beam cursor and select entire model. So all the beams are selected. Click on assign and yes. Now same for the plate, we need to assign thickness. So thickness you will get over here. See thickness in the properties. So click on thickness Let me take for example 5 mm thickness I want. So 5 mm means 0.125 meter, right? 0.125 meter. So type your thickness over here with concrete material, add and close. And this plate's thickness, select your plate cursor and select like this. So all the plates are selected. Click on assign and yes. So this plate thickness is assigned. Go to the rendered view and you will get a water tank like this. See, we have a thickness of this plate, right? You can create a floor also with the help of this plate in your residential bungalow, right? So now you know how to create floor with the help of plates, and also you will get how to assign pressure on this. So as per our problem, initially on the top we have 5 kilonewton, then 10, 15, 20, and at the end we have 30 kilonewton. So in this way we have to assign our load: 30, 20, 15, 10, and 5. So one is missing over here, 25. So we will add that. Okay. So here the main problem is that we need to decide that it's our load. We need to check our load direction. That's the main task. Okay. So just focus over here. Now we have a very less time. So load case, add and close. And in this load case, I am going to add one plate load. In the plate load, we are applying pressure, and let have 30 kilonewton per meter square in local Z direction. Okay, in local Z direction. Click on add and close. Now select this. Go to your particular view. Select your plate cursor and select this bottom plates. Click on assign and yes. And check, you have to check this thing that your load is from inside to outside or from outside to inside. So if you view it properly, then you will get that our load is actually acting from outside to inside. See, for these side walls, right? So this is wrong. And for the bottom plate, see, for the bottom plate, it is actually from inside, right? So for this bottom, this floor, this positive value is fine enough. But for these walls, we need to use negative value. So just delete this and now again add plate load 30 kilonewton, add, and minus 30 kilonewton, add. So this may differ in your problem, right? So first of all, we will assign this positive value to these bottom plates only. These bottom plates. See on this one. Assign and yes. So this entire load is from inside to outside. Okay. Just view it properly. See. It's from inside to outside. It's from top to bottom. And this is correct. And this negative load we will assign on these vertical plates, these vertical plates, these bottom vertical plates, right? These rings. Minus 30, assign and yes. So that load must be from inside to outside, and now it is inside to outside. So we will use all the wall loads, or all the loads for this wall will be negative one. So let me create first plate load -25, add -20, add -15, add -10, add and -5, add. So these are our pressures. Now take the front view, select your next pressure and just focus on this. On these plates, select it, assign, yes. Now this 20 kilonewton, assign, then 15, then 10, and 5. Right? And you have to check that your all the loads are coming from inside to outside, because this is our hydrostatic load of water pressure on these walls, right? So that must be from inside to outside, not from outside to inside. So in this way you have to choose your values. Sometimes it may be different for you also, right? You may have that positive value from inside to outside, so you have to check it. So once you apply your loading, and also if you want to add self weight, then you can self weight, add and close, and this should be assigned to view. Now go to the command analyze perform and run your study. And again we have error. Okay, because we haven't provided support yet. So go to the support, create fix support, and this should be here, assign, yes. Now try to run your study. Okay, good, right? So go to the post process, and here you will get your all results for displacement, right? Beam result, and also we have one new thing, plate result. So in this plate result you can actually get these contours for the different types of stresses. For example, you want to check maximum absolute stress, click on annotate, so it will be annotated with the color contours. Again click on this, I want to check maximum 1 mic stress, click on apply and OK. So this is my maximum 1 mic stress on the plates. So these all are the plate loads. See, we have less stress because here we have beams on the bottom, right? And here we have nothing on the bottom. So in this way you can analyze your study, right? So I hope you all enjoy a lot this session and you learn something new from us, and thank you all of you for your valuable time, right? And stay connected with us, and also subscribe our YouTube channel, right? Okay friends, thank you. And if you have any kind of queries, just contact us immediately without any hesitation. In our all assignment we have our contact number. in our all videos we also have our contact number, so you can contact us. Okay, so see you then.